In this work, we present CipherCard, a unique way of providing two-factor authentication for everyday touchscreens. Touchscreen pin pads are now very common in our daily lives. A major challenge with entering a pin on a touchscreen is that many are designed to be large to accommodate our fingers, making them very susceptible to any casual observer or potential shoulder surfing attacker. To provide two-factor authentication on touchscreen devices and prevent shoulder surfing schemes, we introduced CipherCard. CipherCard is a series of unique physical tokens integrated into everyday objects such as a card, a wallet, and a phone. The core of CipherCard is a card-shaped two-sided PCB with a good layout of touch electrodes on each side. Each side of the PCB is connected with an arbitrary electrical path that is mapped to a different electrode on the opposite side. Using these arbitrary paths, it then becomes very easy to translate touch points to different locations on a touchscreen. As we show here, entering the sequence of numbers from 1 to 0 on the touchscreen pin pad results in an entirely different sequence of numbers being recognized by the touchscreen. In this scenario, a user unlocks a door with the touchscreen pin pad using the card-shaped CipherCard with an observed pin of 1, 2, 3, 4. Without having the CipherCard from the user, an attacker cannot recover identification from observation alone, as the pin 1, 2, 3, 4 on the pin pad is the incorrect pin. Additionally, a user who has obtained the CipherCard will still be unable to unlock the door without knowing the input pattern on the card as well. The wallet-based CipherCard integrates two card-based CipherCards into the design of the wallet. Each of the integrated CipherCards are connected using internal hidden wiring. Much like the individual CipherCard, the wallet-based CipherCard also maps different input to different locations on a touchscreen. In this scenario, a user now uses their wallet-based CipherCard to enter their PIN on the touchscreen. The phone-based CipherCard consists of a mobile phone with configurable software for different pin pad layouts, a SparkCore development module, and a single card-based CipherCard connected to the SparkCore module. The combination of the software and hardware also results in different mappings from a number entered on a phone and a location on a touchscreen. Using the phone-based CipherCard, a user can then unlock a door by first tapping their phone on an NFC tag, which then automatically loads the correct pin layout for the touchscreen. Here, we show a user password of 1234 and a system password of 4817 being remapped to a system password of 6385 using a custom mobile phone application. The mobile phone version of CipherCard allows the user to actively reconfigure a mapped PIN, unlike the card and wallet-based versions. Additionally, using the mobile phone software, a user can trigger multiple input locations with the same button. Here, we show the number 1 triggering both a 1 and a 7 on a pin pad, but to an observer, the number entered is the number 3. Extending this concept further, entering a 4-digit PIN of 1, 2, 3, 4 can trigger 8 numbers and thus confuse potential attackers further. In this work, we illustrated the concept of CipherCard to prevent pin entry on touchscreens from being susceptible to shoulder surfing attacks. CipherCard remaps a user's touchscreen input to different locations on a touchscreen and provides two-factor authentication for touchscreens. For potential attackers who observe a user's pin entry, it becomes very difficult to enter a PIN without both knowing the user's password and having the CipherCard itself.